Hey guys, Mr. Ground here, 8.4 Rational Functions. In this video, we are going to talk about asymptotes. All right, so let's see here, vertical asymptotes. So if we look at the graph of the function from the zeros video, it's this one. And one thing that you may notice is that there's two parts and it's divided by this dashed line. Now, a regular TI-84 is not going to show you this dashed line, but you can kind of imagine it there, that there is a vertical line that can fit perfectly between the two pieces of this graph. If we go back to what the equation of that graph was, it was I believe it was plus 1 minus 3 in its factored form all over x minus 2. Now the location of what that is called, that vertical line is called the vertical asymptote. And if I zoom in, I can see that it cuts through the x-axis at positive 2. Well, if I compare that to my equation, positive 2 is what's going to make the denominator equal to 0. And that's exactly what we're looking for, is when we have a situation where we have a number on the top of the fraction, a non-zero number, over 0, what that is going to do is create, it's undefined, and it's going to create this vertical asymptote in the function. All right. So what we're actually going to do, so what a vertical asymptote is, it's an invisible line that the graph of the function approaches, but it never touches. So if you imagine this one, as this point gets closer and closer, it gets closer and closer, but it never quite gets there. And then from the other side, same thing. It's on the negative side, but it's getting closer and closer, but it never quite gets to 2. By the time you get to 2, it's on this asymptote, and it's undefined. You can get infinitesimally close to it, but you can't. Once you hit that point at positive 2, the function is undefined. Okay, so what we're going to do is we're going to factor the whole thing. We're going to factor the top and the bottom, and we're going to set the bottom ones equal to 0. Just the ones that don't cancel out. Those ones are going to give us, the factors on the bottom are going to give us the vertical asymptotes. All right, so these ones again, now I'm going to factor them just to be sure. And these are the same ones from the zeros video. So just to be sure that nothing cancels out, so for this one, it would be x equals negative 3, would be our vertical asymptote. And it is the equation of a line, so it should be x equals negative 3. That is a vertical line at negative 3. This one is going to be plus 5 minus 3 over x minus 1. Again, nothing cancels out there, so I'm safe to know that x equals positive 1 is a vertical asymptote. If there was another x minus 1, so it canceled out, it would not be an asymptote. It would be a hole in the graph. All right, this one, x minus 2 over x times x plus 1. So now we have 2 of them for that x. That is going to give us an x equals 0. And then for the positive, or the x plus 1, that's going to give us an x equals negative 1. So 2 vertical asymptotes. And then our last one is going to have 2 as well. This is going to be x times 3x plus 1 on top. And then plus 3 minus 3 for our difference of squares on the bottom. And that means we're going to have 2 vertical asymptotes, one at x equals negative 3 and one at x equals positive 3.